Hi, this is Muthu Ramachandran um, from Leeds, UK, and I'm a visiting professor at University of Southampton and also a research consultant for SMEs in the UK and internationally. So today I'm going to talk about a new framework for developing blockchain applications for healthcare. Um, Known as SEF HPCA, which is Secure Sustainable Software Engineering Framework for Healthcare Applications. So I feel this is an important time to make sure we develop applications that are secured, developed with software engineering principles and sustainability, which is one of the key far most important criteria now requested in our software, even from ethics point of view. Okay, so I hope you enjoy the talk. Some of the basic questions I'm going to ask you: what are the key challenges in blockchain for healthcare applications? How do we systematically apply, which is a process and standards, to develop blockchain applications that are secure, safe, and sustainable? In healthcare, in particular, in the healthcare applications are key. There's our lives based on use of the technologies, and therefore we need to spend extra time in analyzing the requirements, designing systematically, and developing and testing it thoroughly. So what are the design principles and what are the reference architecture? Why reference architecture are important? Because that provides standardized way of establishing the structure of blockchain applications, so that in all healthcare applications we will have a uniform approach. That's the key message for adapting a reference architecture for this, and we need to be making it as a standard. Um, what are the services in the reference architecture, where each layer should be mapped and the services onto the layers? How do we classify the technologies and services for blockchain applications? So that way we can have a reusable services across healthcare applications, record keeping or patient monitoring. So there are services that are reusable. So you save time, effort, energy, and cost. Um, there also need to be a classification domain, what is called as domain classification, which are again useful to build a sustainable platform, sustainable form of libraries of blockchains. So people can reuse and develop new blockchain applications in healthcare. And what are the key challenges of sustainability? What is meaning of sustainability in the context of blockchain in healthcare? That's the one of the key fundamental questions I'm wanted to you to explore. You can identify them, Google them, find more discussion, use ChatGPT to find the answers. What are the key challenges of security in HBCAs? So I will be using short forms here, all right? And what the learning outcome of this module, this presentation, are to understand the current trends in healthcare blockchain applications, to identify some of the key characteristics of blockchain relevant to HPCA, because that's more important. If you don't know what are the key characteristics, then we may not be able to address the relevant requirements, the relevant design, the relevant testing, and the relevant implementation. So that's where uh, to understand and to establish a requirements engineering for CEF HPCA framework, to to develop, establish a domain classification for healthcare applications with blockchain. To understand, I've also created a new complexity method known as block points effort. So before you developing application, you can thoroughly identify the complexity and also the effort involved and even cost involved to develop them. So as a project manager, you can clearly know and mathematically from it's derived from the well-established 50 years of or so established concept of known as COCOMO model of estimation. So I'm going to show you a simulation, business process modeling simulation. In particular, I'm going to focus on the requirements engineering for CEF HPCA. So there I will show how you can simulate a business process modeling with a case study of electronic health record systems and evaluation techniques and so forth. Okay, so there are key research challenges, and it motivated me as well because, for example, is blockchain applications growing rapidly in healthcare, includes record keeping, clinical trials, medical supply chain management, patient monitoring, and even medical distribution. In during the pandemic, which was quite hard, internationally we were fighting for for the medicines. So these are the key important where blockchain can help to understand the characteristics of blockchain. In addition, Poru author have reported that we currently lack of process tools, techniques, and standards. So most of the other research questions which I already covered in the previous slide. So the agenda for today, we looked at the research motivation. We'll briefly look at background because you all probably know already some of the characteristics that I've discovered from the literature to understand its characteristics and its concepts and the research trends which we already covered. And then I'll talk about the CEF HPCA framework that I already mentioned, which consists of requirements engineering, domain classification, cost estimation, effort estimation techniques, reference architecture, and a case study and evaluation. And I'll summarize the key points. Okay, so background. So background to introduction or introduction to blockchain. Blockchain is based on a distributed ledger technology which allows secure and transparent transaction between parties. That's the key message for us without the need for intermediary. So nobody can change the nodes, blockchain nodes. So some of the characteristics are decentralization, immutability, transparency, and security, as it is important for healthcare application. Privacy, data security, and data integrity are also crucially important. So therefore, we need have a software engineering approach to develop healthcare applications. So which is what the main form. And there is a simple video when you're leisure you can watch. So what are the key research challenges? So I think currently the standardization of development techniques, process, tools, and technology, in particular security, sustainability, and a lack of systematic approach. What do we really mean by sustainability? So there are two perspectives on sustainability. We wanted to minimize effort by reusing blockchains. This is one of the definition. Secondly, we wanted to develop blockchain which are energy efficient, optimized. So we need to look at how the way in which we have done the implementations and so on. So this is simple ACM digital classification. How do we background to any data structure? How do we timestamp a digital document, which follows some of these concepts information system, data management, data structure, data layout, data encryption, computational theories, complexity and cryptography. That's under the computational complexity cryptography, where you find security and privacy and cryptography. So it's just a general classification. Um, what are the key definitions of blockchain, which is also important? So one of which is blockchain is a distributed data management platform where data may be shared across a distributed network securely with business logic. And another definition, a blockchain is a distributed ledger of transaction implemented as data patched into blocks and so forth. So there are quite a different definitions. This is another key foundation between what we mean by it's decentralized. We need to understand that's the basic. And there's a book written by Bambra and Allen. It's quite interesting book published in Micro Hill, Micra by Micra Hill. So you can see the kind of Dropbox, which is more centralized, even some of the cloud platforms, because they control everything in the central. Whereas a decentralized concept, which is decentralized ledger, it's completely decentralized, as you can see in the diagram. There is no central controller. That's the basic idea. Okay. Some of the core concept of a blockchain is a distributed system of record, which is blocks. It's secured, very verifiable, um, provenance, proof of work, and so on. It's embedded business terms. It offers smart contract concepts to embed some of the business rules and the business contract. Or service level agreement. There's several definition, but smart contract is you can also make smart contract reusable. For instance, within the country, you have a tax system which is uniform for all states, and therefore it's quite easy to reuse that smart contract for tax implications and change the VAT or specialized tax. And it also offers consensus and agreement concept. um, okay, so another way of looking at the blockchain implementation and service model, which is quite important. How do we take blockchain as a block box and off and look at them, what are the services it can provide us? So that's the implementation level. You can see the architecture, hash one timestamp, transaction of records, nuance, and transaction sets, and so on. At the implementation level and the blockchain level, you have number of blocks one, and the blocks can be deployed in a different form: public blockchain, private, and hybrid. And this is value network uh, or, uh, where different type of cryptocurrencies, fintech, digital property, and so on. And the societal services that can healthcare, digital government, and so on. So that's a way to classify the blockchain. So these are the again another key number of characteristics: decentralization, immutability, transparency, and security. Smart contract can help us with developing a secured blockchain applications. So some of the research trends which we already covered, um, I, I think most predominantly from the literature, it shows the security, but I would say sustainability also is quite important. And sustainability, as I mentioned, has a two perspective. One is to develop a reusable blockchain and smart contracts, and secondly, it energy efficient um, blockchains. Okay. This is the structure of a smart contract. In case if you are coming from non-computing background, it has events, inputs to trigger. So there's a status, the contents, and the rules are binded within the smart contract, and they execute. I'll show you in a small code uh, later on. Again, in terms of Ethereum virtual machine, this is how it's structured, how the nodes, smart contract, and storage, Ethereum virtual machines. So that's how decentralized. Um, what is that? Already I discussed what we mean by sustainable blockchain. So the two perspectives, which I already mentioned, a repeatable and reusable blockchains and should be energy efficient. So these are the key. At the moment, it lacks currently the blockchain to develop a repeatable, reusable blockchains and not energy efficient. Um, so now we will move on to the framework. Well, how do we develop a structured way of standardized way of developing blockchain in healthcare and applications? Um, so this is a visualization of a framework known as CEF HPCA. You can see at the top, this is the requirements method, and there's a design method, there is a reference architecture, and the tools or development platforms, and thereby then you develop number of applications, and you also adoption methodologies, and also a number of blockchain testing and evaluation methods, strategies. In particular, smart contract testing, blockchain transaction testing need to do before we deploy. Um, so this is, I'm now move on to the first part of the framework, which is a requirements engineering for CEF HPCA. Um, we need to identify for any simple application what are the functional and non-functional blockchain services. So I call it services because at the requirements level you want to know what are the functional services in electronics, patient electronics record, keeping the patients in the health centers, and then number of health centers and their address and so on. So this is the known as functional requirements, and there are non-functional requirements such as that should be based on the characteristics of the blockchain, such as decentralization, transparency, and so on. So some of the non-functional requirements such as privacy, security, sustainability, regulatory compliance, interoperability, and scalability. So these are some of the. So you can see I've also identified a classification mechanism for requirements engineering for CEF HPCA. So um, into functional, non-functional, you can see the non-functional are based on the characteristics: dependability, extensibility, autonomic recovery, reliability, reusability based on smart contract, low latency, that's where energy efficiency we can achieve, offloading, transaction uploading, energy efficient traceability. I also call to achieve dependability, we can't just achieve at the end. So we need to build in the characteristics. That's one of the other key concept. Then move on, move on to the actual process of requirements engineering or requirements engineering method for HPCA involves you need to have an agreed definition within the healthcare domain. Uh, Identify, build functional requirement, non-functional requirement, build in security, trust into the system, perform risk assessment, identify requirements elicitation, could be a use case model, simply even video of recording the end user requirements, business requirements, and so forth. And then do the classification according to my classification method I showed, and then categorize them or classify them into number of categories: functional requirement, non-functional requirement, prioritize them, and then create a structure for smart contract, map smart contract into the functional, non-functional services, and then do simple validation verification with simulation tools. There are a number of requirements simulation tools. I propose business process modeling tool, which are quite easy and convenient to validate at the first level of requirements. So these are the classification for non-functional requirement, which I already showed in the earlier diagram, but this is more sort of exploded, in particular relevant to medical supply chain applications. So you can see again traceability, interoperability, scalability, integrity, confidentiality, latency, availability, security, performance, throughput, trust, and privacy. Okay. Now we will move on to validating the requirements and validating the reference architecture. So we use what we call business process modeling notation, BPMN for short, well-established technology. There are quite a number of open source tools. I use Bisaki is one of the on tool available online as well as to free of cost to download, which consists of activities represented in kind of rectangle task and sub process notations, simple flowchart notations basically. Event starting of the event, end of the event, intermediate event, timer. If you have a process that has to be respond within a specified time, millisecond or a second, 2 minutes, you don't want to log into healthcare application, wait for ages. So there should be a time out. And then there are decision making symbols known as um, gateways, inclusive and partial, um, parallel and exclusive. So these are the number of PPM and notations. These are the number of tools available. And this is one of my business process modeling simulation with Pisaki. You can see I've taken 100 instance of healthcare record. This is for healthcare record, 100 instance or real-time data request for a health card access. You can see it is going through. At the top it shows the red color completed number of instances, and then the green shows the average time it has taken, and the yellow shows the average time it was waiting. So you can imagine it's in a cloud and the blockchain is deployed, a number of requests coming in real time. So it does through with categories. So there's a quick way of identifying your verifying, validating the requirements before implementation and design. Um, so now we are move on to the domain classification. I believe this is important to establish a sustainable blockchain applications. You can build a library of blockchains, so therefore the future development of the application could be much more efficient and reusable, repeatable. So this is what I mentioned. It's to standardize uh, blockchain application development for healthcare, to build a sustainable blockchain applications in healthcare, to build a reusable blockchain applications in healthcare. So I've just started developing a small classification in healthcare, um, smart energy environment, e-government, identity access management, healthcare, supply chain, financial, the top level classification. So you can also reuse across applications. And then just I've expanded the healthcare, electronic health record, EHR, smart health, image services, land registry, in the e-government, e-health, uh, councils, local councils, and the e-voting. So somehow it need to be collaborative research that we can extend. Um, so now I'm going to show you the complexity estimation based on blocks, block points. So this is the block points. It's a well-established notation equation for calculating software complexity. So blockchain project effort applied, EA equal to, there are constants, A equal to B, the A, B, C, D are constants which are coming from the experience. People have identified those constants. We don't need to worry too much. So A times number of block point in your applications. So identify number of blocks or number of services in a simple term. So each service then break down into number of blocks. How many blocks in the blockchain? So that's the numbers. And it's square of number of block points times human month. This is in human month. Um, and then development time, dt, is equal to c, another constant. Effort applied, you already identified ea, to the power of d, which is another constant. This is in months. So you can see number of service development engineer required. You can identify multiplying the effort applied and the development time. There's another factor for sustainability, looking at the environmental and the people's complexity. So environmental complexity, technical complexity, TCF and DCF, quite useful for sustainability. Okay. Yeah, now um, the reference architecture, which is another point in our framework, the next sequence in the methodology. Okay. So the method should be um, more standardized, which is based on service-oriented architecture, because that's the foundation for software technological evolution that we all enjoy, both cloud, web services, and so on. So that's my reference architecture is based on the service-oriented architecture, known as blockchain components or service models, and then smart contracts. These are a key concept in the design method, design principles. So you can see visualization of uh, a service component model, contract. It has a provider services. It has a number of required services. You then connect them. So pretty much plug and play concept. You can see for security, you can have a quite independent component. So you can then attach them to very different, all different blockchain applications. Okay. So this is another example of blockchain and data processing layer. Okay. So now we move on to the reference architecture, which consists of infrastructure layer, blockchain layer, application layer, and IoT layer. Because most of the data today, if we are getting it from small devices, so which is why I mentioned that the IoT layer. Um, a reference architecture, as I already mentioned, is provides a blueprint for developing uniquely all applications across healthcare systems. So that's the key message. It is also a blueprint of developing blockchain applications. So this is the visual notation for blockchain. So you can see at the top layer AI and IoT. So where AI also can be adapted to pre-process the data, clean the data, on even predicting some services. And then blockchain layer where the actual blockchains are available. This is this blockchain service bus. As I said, this is evolved from service oriented architecture. Therefore, all layers are connected through services. They are not tightly coupled, they are loosely coupled. So therefore the service bus plays a crucial role. And on the side, you have a security layer and sustainability layer, which may be a library of blockchain services. So that's the reference architecture. Now we'll try and evaluate a simple electronic healthcare health record systems. So these are number of use cases: patient registry, electronic number of health in the healthcare record. You have a smart contract, payment service, prescription service, medical devices service. So number of um, this is where some of the services in the reference architecture. So I've started to simulate 100 instances of real-time data request, whatever you call to the EHR. It goes through all the layer, and on average it is taken per 100 instances or 100 in request only 10.45 minutes. So which is quite impressive, going through hundreds of instances in simultaneously. So this is a resource utilization diagram which shows how long for each instance it has taken, and number of resources it has used, in terms of including the some blockchain expertise, AI expertise, and so on. So it's quite a quick way of identifying some of the requirements validation. Okay, so this is another example of smart contract developed in Ethereum programming, Solidity, see patient registry is one contract one, and then you can express the constraints. So it's quite simple to develop for patient registry in Ethereum Solidity. Okay, so evaluation of CEF HPCA. What are the techniques? How do you evaluate the framework? So there are a number of ways, BPM and use case evaluation, which is what we have done in this research. Technical evaluation, more looking at the technical aspect of the technology. User evaluation, that normally we do. Economic evaluation, compliance evaluation, interoperability evaluation, and performance evaluation. So so I'll summarize my talk today. So there is a need for a systematic approach to developing blockchain applications in healthcare, and there is a need for standardization of the process, techniques, tools, methodologies. We started identifying a requirements engineering method, which is quite important, the first level of methodology to establish and agree. Reference architecture we showed, and of course we need a research collaboration to move further, improve our development strategies. Okay, thank you very much for listening. Any questions, I am available. You can always send through the team. So some of the references I have put forward, and there is also more. If you wanted to learn more in-depth introductions of blockchain in healthcare, there are literature reviews and books. Thank you. Thank you for listening. Take care. Bye.